Hey there, Gregory Carlson here, and welcome to the last part of section 5.6 and the last video for chapter 5. So in this example, you notice that we have 5 different equations that we're going to graph. And what I want you to notice is these bottom two. Notice that we have x is bigger than or equal to 0 and y is bigger than or equal to 0. This is really common for application problems, because if you're running a business and each one of these might represent a different function in your business, for example, one might represent workers, one might represent the number of things you're building, your widgets or whatever, it makes sense that those can't be negative, because you can't have a negative worker or build a negative widget or piece of furniture or whatever. So what the effect of these two on the bottom is that it's going to limit us to only being in the first quadrant. Okay, so let's actually take care of that. So x is greater than 0. This is a solid line, x equals 0. And we're going to be to the left of this, we're going to be to the right of this line, because that's where x is positive. And y equals 0 is going to be this horizontal line, and we're going to be above this line. So the effect of these two things together means that our shaded region is going to be limited to only being in the first quadrant. Okay, so we've taken care of these two. So now let's do this one next. 3x plus y is less than 7. I'm going to subtract 3x and 3x. And the effect of that is we're going to get y is less than negative 3x plus 7. So y is less than negative 3x plus 7. So let's go up to 7. 1, 2, 3, 4, 5, 6, 7. And the slope is going to be down 3 over 1, down 3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1. And notice also that it's a dotted line because we don't have the equal sign right there. So it's a dotted line like this. And there's our first line, or I guess our third line. So are we shading above or below this line? Well, y is less than negative 3x plus 7. So less than means we're shading below this line. And so you can see that the effect of this is our shaded region is now limited to this triangle right here. Okay, so we're only going to be shading in this triangle. We still have 2 equations to go, but for now, our only shaded region is the triangle right there. So now let's do this top equation. 4x plus 3y is less than or equal to 24. Solve for y just like usual. Minus 4x minus 4x. 3y is less than or equal to negative 4x plus 24. And then you just divide by 3. So y is less than or equal to negative 4x over 3 plus 8, because 24 divided by 3 is 8. So now let's graph this line. We have a y-intercept of 8, which is 1 higher than this line. And then it's going to be down 4 over 3. So down 4 over 3, down 4 over 3. This is a solid line because of the equal sign right here. So there's our solid line. Now, do we shade above or below? Y is less than the line, so we're going to shade below this line. And if you look at this line actually does not affect our region. And the reason it doesn't affect our region is because it's not cutting through the triangle. However, it's good news that the arrows are pointing down. If the arrows were pointing up, then that means this would have no solution, because our only possible region is the triangle. So if these arrows were pointing up, there would be no solution that would satisfy all of these equations. So although this doesn't affect the triangle, it's good that these arrows are pointing down, because that means this triangle is still working. All right, let's do the last one. 4x plus 3y is greater than negative 12. I notice that this is really similar to this one in terms of I can see that our slope will be the same because x and y are the same. So minus 4x minus 4x. 3y is greater than negative 4x minus 12. And then just divide by 3, which gives us y is greater than negative 4x over 3 minus 4, because 12 divided by 3 is 4. All right, so notice that this line is parallel to this one because the slopes are the same. So the intercept is negative 4, which is right here. And then we will be parallel to the solid line. It'll be down 4 over 3. And it's a dotted line because we don't have the equal sign. Do we shade above or below that line? Well, y is greater than the line, so we shade above. You notice as well, this line does not affect our region, but it's good news that we're shading up because that means the triangle still works. So after all 5 equations, here is the region that is left. And this does not include the dotted line, but includes everything in this triangle apart from the dotted line. And this is basically as hard as these examples get. You've actually reached the top of the mountain when it comes to grading linear equations because, we graphed 5 of them, we saw where the shading overlapped, and found our solution set. So these really don't get much more difficult than this, and congratulations for making it to the top of the mountain. One thing I could do is add nonlinear equations to the mix, like a parabola, but even that's not so bad because all you have to do is just test a point on each side of the nonlinear equation, and then you see if it works or not, and that tells you where your shading is. So essentially, that's all there is to graphing these lines and shading them. In fact, I only have one last example, so let's knock it out now. In this example, they've given us the region, and we need to work backwards to write the equations in standard form. So let's do that and finish chapter 5. Let's start with this line that's decreasing right here. I notice the intercept is 3, the y-intercept, and it looks like we're going through 4 over here, which means our slope is down 3 over 4. So it's negative 3 over 4x. I'm going to put y here, but I'm not going to write my symbol here yet. Our y-intercept was 3, so it's plus 3. All right, now it looks like we're shading below this line. Do you agree with me? So that means it should be less than or equal to. And that's because the line is solid, we're shading below, so it's y is less than or equal to all of that. Okay, let's do the other line. We're crossing through negative 5 right there, so it'll be minus 5. And it's up 1, 2, 3, 4, 5 over 4. So it's positive 5 over 4x and y. And this time we're shading above the line, so that means y is greater than or equal to. So here's the system of equations. The last thing to do is to put them in standard form. So let's write them next to each other. Y is less than or equal to negative 3 over 4x plus 3. Y is greater than or equal to 5 over 4x minus 5. And let's put them in standard form. So the first thing to do is to get rid of our fractions. So let's multiply this equation by 4. That gives us 4y is less than or equal to. The 4's cancel here, so it's negative 3x plus 12. And now let's multiply this one by 4. Multiply by 4, 4, and 4. That gives us 4y is greater than or equal to. The 4's cancel, giving us 5x minus 20. Almost done. To put them in standard form, I just need to move the x over. So plus 3x, which gives me 3x plus 4y is less than or equal to 12. And this one's done, actually. Remember, in standard form, the x term needs to be positive, and so 3x plus 4y is less than or equal to 12. That one's done. Let's finish this one up. Minus 5x minus 5x. Negative 5x plus 4y is greater than or equal to negative 20. And this one is almost done, but we can't have this negative 5x being negative if it's in standard form. So simply multiply the equation by negative 1, and that is going to flip all the signs. But remember, it also activates our rule that we need to flip the sign, flip the direction of our inequality. So this becomes positive 5x minus 4y is less than or equal to, don't forget to flip that, and then negative 20. And now because the 5x is positive, we are done. And we are done with chapter 5. So I hope this was helpful. If you have any questions, please leave them in the comments. Don't forget to like and subscribe, and I will see you in chapter 6.